Here we illustrate the different parts of our usual function f of x. On the left is where we will put our argument, our input. This will then be installed into the function f in the middle, which is a set of instructions that will manipulate the input. The result of this manipulation will appear here as the output. Suppose our function had the instruction to square whatever the input was. It would look like this. If we chose 3 to be our input, the function would manipulate it and turn it to 9. Now for the next row, suppose for some reason we didn't know the input, but we knew that the output was 16. I'm sure you instantly noticed that the input must have been 4. How do we know this? It is because we realized that the inverse function of squaring a number is to square root it, and so we square root 16 and get 4. In terms of our function machine, we have designed a new function to go in the middle, the square root, that turns the output of bracket squared into its input. We find that a lot of functions also have an associated inverse function, like squaring and square rooting. And you are often asked to find these for given functions. I will run through a general method for finding these inverse functions. Have a look at this function here. Again, in our heads, we split this up into the instructions and the argument. First, we are asked to find the inverse function f inverse of x. What I am about to do is the procedure you should always follow for these questions. First, we're going to change f of x and just call it y instead. Y is now the output and x is the input. We now want to rearrange this equation so that we have x in terms of y, a function for the input in terms of the output. We do a few lines of algebra and we get this equation. Take a second to recognize what we are saying. These are the instructions to go from an output to an input. And so the inverse function f inverse is that. The question asks for the f inverse of x, so we simply fill the brackets in with x. The next question is quick. Since we have already worked out the inverse function, we can just input 2 into it, and we get our answer. Take a moment to think about what this final question says. It combines composite and inverse functions. It is saying we need to put fx as the argument for the f inverse function. But think back to the machine on the last slide and look at what we are doing to the input x. First, we are putting it through the function f to get f of x. Then we are putting that result into the inverse function. So the result we will get is just what we put in the first place, x. You can test this for any function and its inverse. And, likewise, you can do it the other way around.